Okay, so today we're going to have a look at a nucleophilic addition elimination mechanism. And we'll have a look at an example with the reaction of water and propanol chloride, which is an acyl chloride. And so if we start off by drawing the acyl chloride, it's propanol chloride, so prop means we've got 3 carbons. And it's a carbonyl compound, so we've got a carbon oxygen bond, and that's our acyl chloride, which is propanol chloride. And that's reacting with water, which is H2O, and I'll draw the facts. I'll draw the H2O, and then when we're doing the products for this reaction, we always know in this nucleophilic addition elimination reaction that one of the products is HCl, which is the Cl from our acyl chloride and the H from what it's reacting with. And then we can see there, if we join what's left, we're forming a carboxylic acid. So we can draw our carboxylic acid, which will be propanoic acid, and we get our HCl. So that's going to help us when we do our mechanism, because we can see what products we're forming. So we can see if our mechanism is going to be correct. So because we've drawn our compounds out here, we can use this to show the mechanism. So if I choose a different color here, so it's called nucleophilic addition elimination. So it happens in that order. And a nucleophile is an electron pair donor. So oxygen in water has an electron pair. And that's going to donate its pair of electrons to the carbon of the carbon-oxygen bond. So if I draw dipoles in here, we don't have to do this for the mechanism, but I think it helps to show where our electrons will go to the positive, delta positive carbon of the acyl chloride. And form a bond with the carbon. Now, we know carbon can't have 5 bonds. So that would make, that additional bond there would make 5 bonds. So what happens is the oxygen takes the electrons from, pair of electrons from the double bond. So carbon goes back to having 4 bonds. So we can draw what we'll end up with here. So oxygen has taken a pair of electrons, so it gets a negative charge. And we've got the water adding on here. So this is the addition bit. The water just adds on to our acyl chloride. And because the oxygen gave electrons away, That's now got a full positive charge. And in the second bit of the mechanism, we lose these charges. So the oxygen loses its charge by reforming the double bond. And again, carbon can't have 5 bonds. So the chlorine, which is delta negative, takes the electrons from this bond. And the oxygen, to lose its positive charge, takes electrons from an oxygen-hydrogen bond. And then if we draw what we end up with there, so we've reformed the carbon double bond oxygen, and we're left with an OH, and a hydrogen ion and a chloride ion have left, so they form the HCl. So you can see the result of our mechanism matches our balanced equation there. We've formed propanoic acid and hydrogen chloride. So in the first stage, the nucleophile adds on, and in the second stage, we eliminate a hydrogen ion and a chloride ion to form HCl.
Right. And yeah, just so a few things that I could ask. Been a while since I did A-level chemistry, but presumably the word nucleophile means it's attracted to the nucleus. So the negative charge on the oxygen ion, on the water, the oxygen atom and the water, the lone pair there.
Yeah, it's simpler to say a nucleophile is an electron pair donor. An electron pair is going to be attracted to a region of low electron density, which is the delta positive carbon here.
And again, that sort of makes sense because chlorine is it will have high electron density since it's raring to go and become a negatively charged ion, isn't it? So in this kind of and GCSE chemistry, you're taught about the idea that it's either ionic or covalent, but obviously at this point there is some degree of covalency and ionicity, if you want to call it that, because of the attraction, the affinity for electrons.
Yeah, and these are very strong or very polar bonds because of the electronegativity of chlorine and oxygen, and it means acyl chlorides are very reactive because of these polar bonds, and this reaction takes place at room temperature. And it's a hard reaction to control, so in a laboratory we often use, instead of acyl chlorides, we'll use ethanoic anhydrides, which we can look at in another video.
Right. Because the water is also polar anyway, so it's got that electron pair, and that's polar, so it's a pretty sort of...
Yeah, and we could show the polar bonds in there as well.
Yeah, it also makes sense that that's the order in which it should happen. So the oxygen has got the lone pair, so it attaches itself first as the addition.
Yes.
And then effectively the other part is when you've got two ions, really. You've got the oxygen oxide ion there and the or part ion, and they got the positive there. So and then the second part is the electrons moving the way they should, and then whatever's left, that's the H plus and the Cl minus joining up. So it's like it's pretty interesting.
Okay.
Yeah. Brilliant. Great one. Look forward to the next one in the series of videos. Nice.
Okay.
All right.